Start with the exercise 6.2. Question number 1. So that the given function fx is equal to 3x plus 17 is increased on R. So fx is equal to 3x plus 17. So derivative with respect to x, f dash of x is equal to 3. Since it is increasing function, f dash is greater than or equal to 0. So function is strictly increasing on R. So that the function given by fx is equal to e raised to 2x is increasing on R. Again fx is equal to e raised to 2x, derivative with respect to x, f dash x is equal to 2 e raised to 2x. This is greater than 0. So f dash implies f dash of x is greater than 0. It is, so function is strictly increasing on R. The function, so that the given function fx is equal to sin x is a increasing in the interval 0 to pi by 2 and decreasing pi by 2 to pi. So fx is equal to sin x. So derivative with respect to x, f dash x is equal to cos x. Since cos x is positive in the interval 0 to pi by 2, if we take 0 to pi by 2 first quadrant, 0 to pi by 2 first quadrant, cos is positive. So f dash of x is greater than 0. Since function is given that it is increasing, got it? It is increasing. Since the function is increasing in interval 0 to pi by 2, okay. So therefore function is strictly increasing. Suppose you take for 0 to pi by 2 close interval, 0 to pi by 2, but here a close interval, then pi by 2, cos pi by 2 is 0, cos 90 is 0. So then in that case function f dash x will be equal to greater than or equal to 0. It will be increasing function, not increasing, but not strictly increasing, but increasing function if it is a closed interval, but here it is given open interval. Okay, the same way here fx is equal to sin x, derivative with respect to x is equal to sin x, derivative with respect to x, f dash is cos x. Since cos x is decreasing in the interval pi by 2 to pi, okay, pi by 2 to pi, cos function is decreasing. So f dash of implies f dash of x is less than 0. So function is strictly decreasing in the interval pi by 2 to pi, is it? If it is close interval pi by 2 to pi, then it will be f dash x will be less than or equal to 0, because it is again pi by 2 0. Neither increasing nor decreasing. Fx is equal to sin x, f dash of x is cos x. In the interval 0 to pi by 2, cos is increasing, and in the interval pi by 2 to pi, cos x is decreasing. So in the interval 0 to pi, the cos function is neither increasing nor decreasing. Interval in which the function, find the interval in which the function f given by fx is equal to 2x square minus 3x is increasing, and second b is decreasing. See, now this is the second type of question. Fx is equal to 2x minus 3x. So with the derivative with respect to x, will f dash is equal to 4x minus 3. To find the interval, equate f dash of x is equal to 0, means 4x minus 3 is equal to 0. So 4x, so x is equal to, we can say 3 by 4. Okay, so what is given? It is increasing. The function is increasing. It means that f dash of x is greater than 0, is it? So you find the interval 3 by 2, here minus infinity to infinity. So minus infinity to 3 by 2, open interval, the function is increasing, is it? The function is increasing in the interval minus infinity to 3 by 2. Same way to find f dash x is equal to 0, again x is equal to 3 by 4. So function is decreasing in the interval, open interval 3 by 4 to infinity. Okay. Find the interval in which the given function f given by fx is equal to this is increasing or decreasing. Fx is equal to this, with respect to x, f dash of x is equal to 3 to the 6x square, 3 to the 6x minus 36. Is it? So here, if you factorize this, okay, a, if you factorize this, you will get what value? X is equal to 3 and x is equal to minus 2. Is it? If f dash is equal to 0, so you will get that what is the value? 3 and minus 2. So minus 2 and 3. Is it? So where it is increasing, where is decreasing, that you have to find. So in the interval minus infinity to minus 2 union 3 to infinity, f dash x is greater than 0. Okay, hence the function is increasing in the interval minus infinity to minus 2 and 3 to infinity. Got it? Minus infinity to 2 and from 3 to infinity, this function is increasing. How to find it that? Now you understood how you got it. Take this interval first, minus infinity to minus 3, minus 2. So this is the first interval. Take any value, say minus 3. Substitute here it is minus 3, minus 3. So minus 6 and minus 3, 2. So it is minus 1. Is it? What you get? Minus 6 into minus 1 plus 6. So it is a greater than. So value is positive. So greater than. So the function is increasing in the interval minus infinity to minus 2. Let's check it for this one. Any value in between these two. So 3, 2. Can you take 2? Or minus 1 also you can take. Check 2. 2 is equal to what you get? Minus 1. And here 2. 2 2s are 4. And here you will get minus 1. So 4 minus 4 you will get. Minus 4 is less than 0. So the function is decreasing in the interval minus 2 to 3. Now let's check between 3 to infinity. 3 to infinity means 4. If you take 4, put here 4. So 4 minus 3, 1, 6. So it is 6. Got it? Which is also greater than 0. Got it? So it is a function is increasing. So in this interval minus infinity to minus 2, the function is increasing. Union here also from 3 to infinity, the function is increasing. So function is increasing implies that f dash of x is greater than 0. Okay, and in this interval we have checked minus 2 to minus 3, the function is decreasing. So in the interval minus 2 to 3, f dash of x is less than 0, hence the function is decreasing in the interval minus 2 to 3. In which the following function are strictly increasing and decreasing. Is it E? You're not done. E. Is it? A, B, C, D, we are not done. So you factorize it and do it in the same way as we did it. Let's take, for example, this one E. Fx is equal to x plus 1 raised to cube into, what was that? Into x minus 3 raised to cube. Okay, derivative with respect to x. So it is u into v form. So first we'll take the derivative with respect to power. So 3x plus 1 whole square. This will remain as a constant, plus this will remain as a constant. Okay. X plus 1 raised to cube into, we'll take the derivative of this, 3 into x minus 3 whole square. If you take it common, x plus 1 whole square and x minus 3 raised to 2. Okay, then inside bracket we'll get x minus 3, here x plus 1. If you simplify, you will get 2x minus 2. If you take 2 common, so it will be multiplied here, 6 x plus 1 whole square, x minus 3 whole square plus x minus 1. Okay, where did it become 0? X, f dash x is equal to 0. Is it? It is a strictly increasing and decreasing function. Where it is increasing, decreasing, we have to prove. Is it? What is the question? Find the interval in which. So where it becomes 0, here if you substitute x is equal to minus 1, x is equal to 3, x is equal to 1, this becomes 0. So this is not equal to, so x should not equal to minus 1, x is not equal to 3, or x should not be equal to 1, or we can equate it to 0 and get the value of x. Is it? So what we get, minus infinity to minus 1, then we'll get 1, 3 and plus infinity. So these are the 4 interval we got, 1, 2, 3, 4. Okay, is it? Any value you take and substitute and get the value here. Suppose minus 1 and infinity. Is it? This function is decreasing. Function is decreasing. Substitute the value and see. Any value between half, or do you say any of half value in between minus half. Okay, or you can say substitute this 0 also. 0 also you see, x0 x0. So what will get? 0, minus 1, no, minus 1 is positive, so minus half you have to take, or minus 2 you have to take. Minus 2 you take and substitute the value and get whether it is coming less or not. So it is a minus sign, so it is decreasing. Again in between 0 and 1, minus 1 and 1, so you can take 0 and find out the value of it. 1 and 3 you can take 2 between this, and 3 greater than 3, 4 you can take and substitute the value. You will find that whether it is a decreasing or increasing. Is it? So minus infinity to minus 1 interval, the slope of a function f dash of x is less than 0. Okay, decreasing, so the nature of the function is decreasing. And minus 1 to 1, it is again minus, so f dash x is less than 0, so decreasing. 1 and 3, f dash of x is greater than 0, it is increasing. Good. Okay, and 3 to infinity, the function f dash of x is greater than 0, it is also increasing.